right, so let's take a look at unit conversion. It's something that comes up quite often in physics problems. Most of the units that we'll be dealing with in physics are going to be metric units. And there are a couple of different ways to teach metric conversion. We can talk about simple movement of the decimal point, and we can also talk about dimensional analysis using equivalences to do the conversions. I'm a big proponent of just simply moving decimal points anytime you can. The metric system was set up to be easy. It's a base 10 system. And the main reason why it's a base 10 system is to allow for easy conversion, to make the conversion nothing more than moving the decimal point around. Every time you do a metric conversion, you're simply multiplying or dividing by some multiple of 10. So you're just moving decimal points either to the left or the right to do your conversions. There's no real math involved like there are with the English ones. So let's start there. To do the conversions the easy way, simply moving the decimal points around, you need to know your basic metric prefixes in order from largest to smallest. They are kilo, hecta, deca, followed by the base unit. Those are the three prefixes that are larger than the base unit. Kilo is 1,000 base units, hecto is 100 base units, and deca is 10 base units. So kilo, hecto, deca. Then you have your base unit, and the base unit is meters, liters, grams, whatever. Then you have your three prefixes that are smaller than the base unit, deci, centi, and milli. Deci is a tenth, milli is a hundredth, or centi is a hundredth, and milli is a thousandth of a base unit. So deci is 0.1 base units, centi is 0.01 base units, and milli is 0.001 base units. Kilo, hecta, deca, base, deci, centi, milli. The mnemonic device that's taught lots of different places in order to remember that is the sentence, King Henry died by drinking chocolate milk. The K in king for kilo, the H in Henry for hecto, the D in died for deca, the B in by for base, the D in drinking for deci, the C in chocolate for centi, and the M in milk for milli. It makes the metric conversions pretty straightforward, as long as you're within those 6 basic prefixes. So if in one of our problems we had to convert 35 centimeters to meters, we would first think about where we're starting and where we want to end in that string of prefixes. And again, it is King Henry died by drinking chocolate milk. If you need to write that down somewhere on a paper when you're doing a test or a quiz, then do it. Write it in the margin right at the top somewhere. We need to think about where we're starting, centi, so we're starting right here. And then we need to think about where we're going. We're going to meters. Meter is a base unit, so we're going to be ending here. We're going from centi to base, which is 1, 2 places to the left. Again, we're starting at centi. We're going to go 1, 2 places to the left. So we're going to take our decimal point, which we assume to be right here at the end of the number, and we're going to move it 1, 2 places to the left, meaning that it'll end up in front of the 3. In science, we tend to put zeros in front of our decimal points because it does set it off as a decimal point. There will be no confusion for what that is. That we would know is a decimal point. Let's take a look at the second one, convert 5.3 kilometers to meters. Again, we have to look at where we are and where we're going. We are starting with kilo, and we're going to meters, the base unit again here. So from kilo to the base unit is 1, 2, 3 places to the right. So note we don't count where we start. Starting at kilo, we're going to go 1, 2, 3 places to the right. So that's what we're going to do with the decimal point. We're going to take it and move it 1, 2, 3 places to the right. And there's going to be a couple of zeros we're going to add into this to fill in the empty place values. We move from here to here. That one was easy enough. But then when we moved the last two places, they were empty, so we throw zeros in those empty place values just to hold them. So that's the simple way, that's the straightforward way of doing a metric conversion that doesn't involve anything more than moving the decimal point around. The only time that this is going to fail you is if you go beyond the 6 most commonly used prefixes. If you're staying within kilo to milli, you're fine. But there are some times in physics where we go beyond just those 6 basic prefixes. We could need prefixes that are larger than kilo. We could need prefixes that are smaller than milli. And when those happen, when we come across those and we need to do conversions with them, we need to use dimensional analysis, the process by which we do our unit conversions with equivalences instead. Again, the 6 basic prefixes, kilo, hecto, deca, deci, centi, milli, are the most commonly used ones. Kilo is the largest of those 6. A kilo is 1,000 base units, so a kilogram is 1,000 grams. Beyond kilo, we have mega, giga, and tera. Those probably sound pretty familiar to you because they are used in computing. Megabytes, gigabytes, terabytes, megahertz, and gigahertz. They come up often when we're talking about computers and processors and memory and Wi-Fi. These 3 prefixes are becoming a part of our normal everyday lives. Mega is 1,000,000 base units. That one's pretty easy to remember because the lottery game, Mega Millions. Mega million. A megabyte would be 1,000,000 bytes. Giga, that is 1,000,000,000. So a gigabyte is 1,000,000,000 bytes. And then tera is 1,000,000,000,000. So a terabyte would be 1,000,000,000,000 bytes. Mega is 1,000,000, giga is 1,000,000,000, tera is 1,000,000,000,000. There are others that go beyond that, and I'm sure one day they'll become more normal to us as we move beyond things like terabytes. But these are the 3 that I've seen before in physics. Milli is a thousandth of the base unit, 0.001 base units. But there are some that go beyond that. These are seen oftentimes in biology when you're talking about the size of cells or viruses or parts of cells. They're also seen in physics when you're talking about wavelengths for high energy electromagnetic waves. Micro is 1,000,000th of a base unit, 0.000001. Nano is 1,000,000th of the base unit, and pico is 1,000,000,000th. Now note, I'm pointing this out in both of these, you'll note I didn't put any commas in here. Scientists don't use commas in numbers because commas can be mistaken for decimal points. In fact, in Europe, commas are used instead of decimal points. So we don't use commas. If you want to break up your sets of zeros, you can use a space like I did here, but it's best to avoid using commas. So micro is 1,000,000th, nano is 1,000,000th, and pico is 1,000,000,000th. Again, there are some past that, but they're seldomly used. To do the dimensional analysis with these equivalences, we're always going to start with the given measurement, and we're going to multiply that given measurement by a fraction. And that fraction is set up to cancel out whatever unit you're given. Remember, in math, for something to cancel, you need it in both the numerator and the denominator of your equation. So we use this fraction in order to cancel out the given unit by putting that given unit in the denominator of the fraction. The numbers that go into the fraction come from the actual equivalence that you're using. So the way we set it up looks just like this. You start with the given measurement, whatever you're trying to convert, times, and then a fraction bar. On the top of the fraction, you use whatever number is attached to your unknown unit. The unknown unit is simply what you're trying to convert it into. And then the number that goes on the bottom of your fraction is whatever unit you were given here. Whatever unit's attached to this given number, that goes on the bottom. And again, the point is to cancel that given unit out. So we wanted to convert 0.005 meters to micrometers. We're going to need the equivalence. And the equivalence that we had from the previous slide is 1 micrometer. 1 micro is 0.000001 base units. So 1 micrometer is 0.000001 meters, or a millionth of a meter. The abbreviation for micro is this Greek letter. So again, to set this up, we start with a given unit. The given unit is 0.005 meters. So that's what goes first in our equation. Times, and then the fraction bar. What goes on the bottom of the fraction is whatever has this given unit attached to it, whatever has meters on it. And the number with the meters on it is the 0.000001 meters. So we're going to put that on the bottom. And again, the goal is so this unit's going to cancel out. The unknown, what we're trying to convert it into, micrometers, the 1 micrometer goes on top. Now, generally, we can ignore ones. So if the number that's not 1 is on the bottom, we'll divide by that number. So it's 0.005 divided by 0.000001. You could throw the 1 in there if you care to. 0.005 times 1 divided by 0.000001. But you're just punching extra things in a calculator. And anytime you're punching extra things in a calculator, that increases your chance of missing a button, hitting a wrong button, and making a mistake. So I would do 0.005 divided by 0.000001. You end up with the number 5,000. Now, as far as the units are concerned, because the meters are in the numerator and the denominator, they will cancel out. The only unit we're left with is micrometers, and that ends up being the unit for our answer. That's dimensional analysis. When you're stuck doing the dimensional analysis, you may have to do more than one conversion to reach your final answer. In those scenarios, you're typically doing something like converting from nanometers to centimeters. We don't have a direct equivalence for that. There are no 1 centimeter equals so many nanometers. But both of those units can be related to the meter, and the meter ends up being that base unit, that intermediate unit that we use in between the two. So let's say I want to convert 0.000003 megameters to kilometers. I would use my equivalence with megameters and the base unit in it first. And the goal of this dimensional analysis conversion is just to get this number into meters, something I can use. I start with my given, the 0.000003 megameters, times, and then the fraction bar. The number that's going to go on the bottom is going to be the number that has the unit megameters. That's the 1. And again, the goal is because of unit cancellation. I need my numerator and my denominator for the units to cancel. The other number, the 1 million meters, goes on top. Again, since megameter is in the numerator and the denominator of my equation, it will cancel out, leaving with meters. Again, meters isn't what I want kilometers, but I can use meters to get there. I can get to kilometers from meters. The million's on top, so it's 0.000003 times a million. That gives me 3 meters. Now I need to get that kilometers. I could do another dimensional analysis problem, since I know that 1 kilometer equals 1,000 meters, and I can use that equivalence to do it. Or I can do my simple conversion using the prefixes. I've got meters. I need kilometers. I'm starting at the base unit. I need to get over here. That is 1, 2, 3 places to the left. So I take the decimal point and I move it 1, 2, 3 places to the left. Just remember, if there's no decimal point in your number, it's always at the end. I'm left with these 2 empty place values that I have to fill with zeros. So my answer, 0.003 kilometers. Again, a multi-step problem because I'm combining these units that we don't have in our kilo hectodecabase decentimilli sequence with something that is.